Okay, look at what I have written in red. What's the difference between this and what you were seeing in your homework last night? There's an equal sign. Okay, so this is what we are doing today. We are going to verify or prove identities. Okay, I want you to verify to me that this equals this. Now, big thing here. This is not an equation. It's not an equation. It's an identity. I'm telling you that this equals this, and you need to show me that that's true. And you can do that in one of three ways. You can manipulate the left side until it looks like the right side. You can manipulate the right side until it looks like the left side, or you can manipulate both sides until they look like each other. But you know when you are done when you have the left side equals the right side. And that feels good, that we have like a goal. Okay, you're looking at me and laughing. Are you like worried about this? Oh, this is so much better, Jalen. It's so much better. Okay. You cannot move anything across the equal sign. When I say manipulate, I mean use trig identities, use algebra. But whatever's on the right stays on the right. Whatever on the left stays on the left. But we manipulate with algebra or identities until both sides are equal. And then we're done. It's better than yesterday, not knowing when to stop. And guess what we're doing for the next 4 days in class? Doing problems. Like, I'm not teaching you anything new. Tomorrow, we're just doing more problems. I'm not teaching you anything new Monday. We're just doing more problems. Okay, so I'm going to talk through some strategies. I wouldn't necessarily say you have to write these down, but you can if you want to. Okay, some of you are feeling frustrated from last night's homework. Okay, so now that you actually like know what the heck I'm talking about, let me give you some strategies. Okay, I feel better about doing these problems because I know when I'm done. As long as the right side equals the left, then I can stop. Okay. But how do you know where to start? Every problem is different. And what's really nice about this is my work could look different than your work, but that doesn't mean you're wrong. Okay? There's a lot of different ways we can do these problems. Does that always happen in math class? Not really, right? Usually it's pretty black and white. There's a lot of gray area in these problems, okay? Which for some of you, you like, some of you maybe not, okay? So I don't know if you need a reminder or not, but you cannot move terms across the equal sign. That equal sign is a brick wall. Nothing goes through it, okay? Do not move to the other side, okay? So what are you gonna do when you see an identity? Well, you can be prepared to think like these aren't going to come easy. I think you already understand that. Okay. But giving up is not an option. Okay. It might be helpful to start with the more complicated side. So maybe you have like one term on the left side, but like 3 terms with a fraction on the right side. What's that side? If it's more complicated, you can manipulate and condense until it looks like the left side. Okay. So what if they both look complicated? If there's addition and subtraction on one side versus multiplication, division on the other side, choose the side with addition and subtraction. Why? You can make common denominators and add it together. And more than likely, you're going to get something to be able to substitute or cancel out. Okay. Always be on the lookout to make substitutions. So keep in mind those 3 groups of identities. If you see a 1 over cotangent, you can switch it to tangent. If you see sine squared plus cosine squared, you can change it to 1. Always be on the lookout for those identities. Okay. Don't forget that factoring is our friend. Look for a GCF. Maybe you can factor out a GCF, okay? That's probably going to be the most common type of factoring you're going to need to look out for, okay? If fractions have a common denominator, you can add them together, and that helps you to condense one side, okay? Or there's even the other way where if you have more than one term in the numerator, it could be a possibility to break up the fraction into this plus this, okay? Now, I would not use both of those in the same problem. Don't get common denominators and then the next step, break up your fraction. You're just going backwards, okay? You need to move forwards, okay? If you're really desperate, you have no idea what to do, change everything to sine and cosine. That would be like a last resort if nothing else is working, okay? The biggest thing though is that you can't give up, okay? Giving up is not an option, okay? Like we just discussed, if you don't practice these problems, you're not going to get better at them. And unfortunately for some of you, it's going to be a productive struggle. I say unfortunately because not all of us like that, okay? Some of us don't mind it. Some of us don't like it. But a productive struggle is just something that you're going to have to accept, okay? You're not going to be great at these right away, but the more you practice them, the better you get, okay? Speaking from experience, Nick, you've done these before, right? Would you say that that's true? The more you do, the better you get?
No, I think it just stays as hard as
Nick.
It does. It doesn't. I thought it was really hard yesterday.
Okay.
I think I
Okay. Well, that backfired on me. Write this down. Write this down. What is going to happen is, as a class, you're going to talk me through this problem. And then in partners, I am going to give you 2 problems to work through. Okay. However, look at this. Look at this. The problems I give you, the steps are there. You just have to put them in the right order. Okay. Okay. So what are we going to do? Brock, you have an idea?
Yeah, because initially I solved it wrong and I ended up backwards. And put it back. So try it again. So first of all, you want to you want to change tangent of x to or that'd be sine of x over cosine of x,
And then cotangent also. Okay, so Brock decided that maybe we could take the left side and make them fractions, okay? Do you remember how in my hints, I said if one side was addition and the other side was multiplication, choose the addition? Because with addition, if we have fractions, we can make common denominators. So let's try that. Tangent is sine of x over cosine of x. And cotangent is cosine of x over sine of x. Now, guess what? The right side is still there. And we use the quotient identities. We're going to, if you don't change the right side, you still have to write it, okay?
Do we have to give you a routine, like, on the side on the test?
Yes. I do want you to give me what you're doing in each step. For you, in case you make a mistake, you can follow your thoughts. For me, when I'm grading, if there is a mistake, I can figure out which part, like what you are trying to do, and help guide you
So you
to
take
fix. How are you not gonna do it? Like, you're gonna do it. It's gonna be fine. Like, oh, you can make abbreviations, Katie.
Why did you not do tan over 1 plus 1 over tangent?
You could.
So, okay.
Yeah, you could do that. I would say that it's 6 one way, half a dozen the other. Okay, because you're still gonna have to make common denominators, and you're still gonna end up using a Pythagorean identity. Okay. Half a dozen. Okay, okay. So Katie, if you want to do that in your notes to see if you go for it. Okay. And Katie brings up a good point. Remember, we're not all gonna see this the same way. Your work could look different than your neighbors, and that's totally fine. It's not wrong. Okay, unless it is wrong. But okay, so now we're adding two fractions. What do we need to do? We're adding two fractions. What do we need to do? Wow, people. We need common denominators. So this has cosine, this has sine. So this guy needs to be multiplied by cosine over cosine. And this guy needs to be multiplied by sine over sine. Wait, what? Why is this horrible?
Like, do whatever you want.
You can have both sides.
Like, you can just like change it.
Well, the whole point is to change it, but we're changing it equivalently. Okay, it still represents tangent of x plus cotangent of x. We're just making it look different. Okay. Now, we have made a common denominator of cosine of x times sine of x. Do you agree?
Yes.
Okay. This numerator right here is sine squared. And this guy right here is cosine squared. Because all we did is we added our fractions. Now, if you wrote add fractions and I wrote combine fractions, I'm not going to be picky about that. I understand what you mean. Okay. I just need to be able to follow your train of thought. Okay. Okay. Now, okay, never mind. In our numerator, do you see something exciting? I think you are right. Sine squared plus cosine squared is a Pythagorean identity. That, what? What do you mean?
X divided by sine X.
That would be sine. So that was our Pythagorean identity, and I don't really like spelling Pythagorean, so I always like to shorten it. Okay, now at this point, we can stick with the left side, but it's totally fine if you want to go to the right side too. I don't care. Some of you are going to have a little bit of like, I want to stay on just one side. Yeah. What's 1 over cosine the same as? Secant.
Oh, wait, no, I thought.
And what's 1 over sine the same as? Guys, look what just happened. Are our two sides the same? Boom, we're done. Sorry. Hey, isn't it nice having an end goal? Okay, and like I said, so like on this problem, we only worked on the left side. Maybe another problem, you only work the right side. Or maybe you do a little bit on the left and a little bit on the right until they're equal. It doesn't matter, as long as you get to mathematically correct, left side equals right side. Thanks. Are you okay, Isaac?
No,
Why?
no.
There's
There's
so
so
much.
You just like
Like a
change it
couple.
to literally whatever you want.
Now, whatever I want. Well, she doesn't know the rules yet, because she doesn't want you to do. Once you have the rules, this makes a little bit more sense. Okay, this is what we're gonna do. I'm gonna hand you and a partner 2 pieces of paper.